Hello my friends, welcome again to my video channel. Rode in Schwarz EK070, a heavy beast from the late 70s. I found in the manual schematics from 1979. The manual itself is dated 1981. It's a shortwave receiver, 10 kHz to 30 MHz for all modes which were necessary in those days for commercial applications. AM, FM, SSB, also teletyping. Thought for connection of an old mechanical teletyper, not an electronic one. Electronic one could also be connected, of course. There are enough outputs on the rear side. Frequency input, mode selection and so on. Also a VFO knob. And other features. It is fair because there is a problem. Sometimes it's okay, it's working, sometimes not. So we'll have a look at it. Let's start with the rear side. It's a power supply. Here we have the remote control connection. IC with address setting, it's known from those days. This is a spare for an additional unit. There's a screw missing, okay. This is teletyper output. Here the current for the teletyper can be set for the current for the coil of the teletyper. This is IF output. Here we have the panorama. Let's see, option to connection a panorama adapter. P3. I know a P3. It's from it's a modern type. Okay, here we have the 1 MHz reference frequency, intern extern, oscillator 2, and here we have oscillator 1. The first IF is the range of 80 MHz. Antenna, remote control, everything which is needed in those days for a commercial receiver, also for automatic surveillance of frequencies, can be controlled here. These transceivers were built for many applications in the intelligence services, military, commercial applications. So a remote control is always useful, and connection to computers in those days. Simple connection to simple computers, but it worked also. On the front panel we have many knobs and so on, VFO knob. Here we have the modes A1, A3, steps for the VFO, AGC, fast, slow, manual gain control, HF, RF. It's for local and remote control, can be switched. Looks a little bit broken, doesn't matter. Here we have the frequency input. This is a frequency display, 1, 2, 3 up to 9, plus, minus, channel select. There's a threshold, I think it's for the RF gain, VFO setting. Speaker, okay, when it was brought to me it worked, and then it worked not. It worked again when I switch it on. I try to switch it on. Generally it works. Same trouble again as I had in the project before. It works. Should be the illumination. Okay, yes, it works. A little bit weak. Well, not a problem in the moment. Well, here we have a test knob. I think I will use a test routine. There's an internal test routine to check whether we have a problem. Switch it off. Wait some seconds. Okay, comes back with the same setting. There's a buffer battery inside. Maybe the battery is weak, but it would only cause a loss of the setting, of the actual setting, but it came back with the right setting, so I cannot see any problems. Well, there's a test routine described in the manual. Let's start with the test routine and see whether we can find or identify any problem. Before we start with our work, we should have a look into the concept of this receiver to understand how it works, what the specialties are, and where we should look at it. This is a part of the advertising sheet. We have here a pre-selector. Sorry about it's only in German language, but I hope it's acceptable for you. These are 10 filters, sub-octave filter, to reduce the intermodulation of second order. That's important. We have here a first IF of 81.4 MHz with the oscillator PLL. Then we have a second mixer down to 1.4 MHz. So we have a very high first IF and then a very low second IF, 1.4 MHz. And there we have 8 filters, maximum 8 filters, switchable. The 2 oscillators here for the mixer are controlled by PLL loops. And the third output is a BFO itself. And then we have the different demodulators. AM, FM, here we have SSB, with the BFO you have A1, this is CW, and here we have output for teletype demodulation, AF output, and the whole receiver is controlled digitally, all analog stages. This is a pure analog concept, are controlled by digital controls with the control unit, Steuerwerk as control unit, with keys, displays and so on, whatever is necessary and what we know from other concepts from those days. This was, I think, the best compromise in those days, which could have been made. Compromise between analog technology, which was proven in those days, and digital requirements. And we have here BCD interface, input-output for data. The output for data, and here we have the IAC bus for control V24 interface to control the receiver and to read the settings like frequency and so. Here we have the same block diagram a little bit more in detail, where we have the input filters. Here we have a test, it's a noise generator to check the receive function. Here we have the first IF. This is part of the PLL. We see it's a little bit more complicated. It's not only a simple block. There are a lot of frequencies involved. We may come to this topic later when it is necessary. Here we have the IF chain panorama output to connect one of the panoramas adapters of those days. Here we have the IF 1.4 MHz, and everything you see green here is the control bus, which controls everything and reads data if necessary. The IF filter section has a little bit of speciality. There's reception for A3B, that is independent sidebands on the AM. There is a switching matrix, and here we have USB. This is untere Seitenband, this means lower sideband. It is switched to this separate output, and the upper sideband, the OSB, obere Seitenband, is switched to this output. Here we have the IF of 1.4 MHz, and here we have the other sideband in case of A3B reception, which is fed directly through this connector to the demodulator. So we have 2 signals, and here we have the other signals for CW, RTTY and so on. They are all switched to this output IF 1.4 MHz. And this one, the lower sideband, is switched to this pin. Makes it possible to demodulate independent sideband AM transmissions. Here again the IF section with the filters. That's the IF signal, and here we have the lower sideband, untere Seitenband, which goes to this chain here, and it is demodulated and can be selected upper sideband, lower sideband, also in case of AM And these are the demodulators, the BFOs. BFO is switched here. It's a frequency in the range of 1.4 megahertz for both sidebands. And here we have the frequency generation, of course. And this can be selected, and this goes to the volume control and goes back into the amplifier, where we have the speaker and other controls, speaker on off and so. Here are any additional outputs for TTY. The signal is also fed to this demodulator for teletyping output to make it possible to connect a teletyper, an old mechanical machine, or even a so-called modern computer. Here we have the control unit, CPU, keys, EEPROMs, RAMs and so in output, setting the address for the IEEE bus, V28, input, output, interface for data. The data, it's also the control bus for serial data. And here we have the power supply. It's obviously a truly analog power supply. I don't see here any switched mode. Power supply is 30 volt, 12 volt, 14, plus minus 5 volt. And there's a supervision of the voltages, and here we have the bulb on the front, the indication it only is lit when the supervision says yes, it's okay, and all the voltages here are supervised. And when they are okay, only in this case, this LED or bulb is lit, otherwise not. Well, that's it. Now we'll start with a test whether we can reproduce the fault which the owner claimed. Now it's time to start the test routine, the self-test. This routine does two things. First, all LEDs in the knobs are lit. This here and this here. And the second is a noise signal is generated, which can be heard in the speaker for a second. First we will check the LEDs. When I go to test, all LEDs and also this here, I repeat it, and it goes back, no problem. So the test goes off. And now to the noise. The mode is SSB, upper sideband. You will hear a noise. It was a very short pulse. Lower sideband. Test, okay. CW, narrow bandwidth. We always hear the test. The manual states also we should check the function of the VFO knob. It is switched on, it works. Manual gain control. This is slow. When I go too fast, also works. SSB mode. And you see here the dB level. Maybe it's difficult to see, the LCD is a little bit weak. Here we have LED, the LCD for microvolt. So we can say MGC also is okay. And now we do a test with a signal generator. We will feed in a weak signal and listen to it whether we can hear it. Now we have a 14 megahertz signal from the signal generator, 1 microvolt, upper sideband. I go to the lower sideband. Go down to 0.3 microvolt, 0.3. This is 0.1. Okay, it disappears in the noise. it works. I will check it on other frequencies, but I think, or I'm sure, by the way, I would reduce the bandwidth. First test. Here it is. We see here the indication of the tuning, minus, plus, looks also okay, and then I can reduce the bandwidth. Hertz, steps 10 Hertz. Okay, this is a very sharp filter. The knob is not balanced mechanically. Counterweight is missing. But it's operating very well. Go down to 0.1 microvolt. Okay, the generator isn't completely tight, maybe a little bit more than 0.1 microvolt. But we can still hear it. No problem. Here we have an AM signal modulated with 1 kHz, approximately 80%. 6 kHz bandwidth. Three kHz bandwidth, 1.5. Okay, 600 Hz bandwidth with AM makes no sense. 12 kHz. Well, AM also works. Another check is all modes. I cannot show you the FM demodulation because it's only for teletyping, not for speech. So it makes no sense. But we can check the S meter. I feed in a signal of 10 millivolt. And we should have an indication of 80 dB microvolt plus minus 5 dB, which we reach. That's okay. The level is also level indication. That's a mode. Where are we? SSB. In mode FM we also have the same signal strength. Still 14 megahertz. Plus minus F1. A3. It's a carrier unmodulated. And with the SSB. Well, I think there is no problem. I also checked the function general storage and recall. It's okay. BFO setting can be changed. Only data in the address setting I cannot check whether it's correct because I have no data connection to it. In the moment I cannot identify any problem with this receiver. But I remember when I switched it on with my friend, there was a problem for a short moment. Maybe we have a contact problem inside. There are many units which are plugged. Or we have a problem with an electrolytic capacitor in the power supply or similar. It cannot be a heat problem because the receiver is still rather cold, and especially when we switch it on after a longer time of resting, it is not overheated. I don't know in the moment what the problem is and where to look for it. I will open it. Maybe I will find a problem in the power supply, and I admit I'm a little bit curious about this. There's a big cover. The paneling on it, I will remove it. A lot of screws, 2 or 3 are missing. I replace them and have a look into the receiver. Now it's time to open the receiver to do some checks. I want to check the battery. I'm not sure whether the battery is still okay. And the power supply. I remove the top cover. Here we have the power supply. There are some electrolytics. I will check them. This unit here is missing. It's an option. As I understood, it's another interface unit. And you see all components, all modules are screened, totally screened with a sheet. And then here we have a lot of contacts. It's built like a tank. I've never seen such a receiver. Well, the battery is here on this unit. It's a control unit or processor unit. Here we have the buffer battery inside. Can be taken out rather easily from the bottom side. This is the bottom side. You see here it's built very clean. Some HF connections for the oscillators, IF and so. It's built very precise. Again, built as a tank. Here we have the screws to fix the power supply. I think there are some screws here. And the processor unit, I assume I have to open this screw, and then I can take out this unit in this direction. Of course I have to unplug this connector, whatever it is. I don't know what signal is this. I will check it, and then I can take out this unit into this direction. That is the build. Yes, here we have a slot on the side, so we can take it out in this direction. Same applies of course for the power supply. I think I will take out also the power supply and check the electrolytics. Optically I do not see any problems, no signs of leakage. They are all okay. Also this vent here is okay. It's not blown out, also not blown out. I took a mirror, looked under it, and it's also optically, I say optically okay. That means everything and nothing. But my first step is to check the battery inside here and take it out and see what the battery says. The module is out, indeed only 2 screws. I use a ground strap. For Her Majesty I use it. And then, as I understand, this is the component side. Remove screw by screw. And put the damned screws in a box. Okay. This battery is from 97. 97? Could it be the year? Okay. Could be. Could be. What is this? It's exactly above this. Looks like an EEPROM or so. Yes, be careful. Hey, guy, be careful. Not to erase it. Do not erase it. Well, I will check the battery. I'm checking now the battery. Hope you can see it. I think yes. The voltage should be 3.7. 3.6. Sorry. 3.695. And for voltage below 3.5 it should be replaced, so the battery is okay. 3.695. I will make a note in the manual. The processor board is in again. This is a 5 MHz clock derived from the oscillator part. This 5 MHz is needed for the processor. Okay, next step is the power supply. The power supply is fixed with 2 screws from the bottom side, same as the, for example, processor unit, which had these 2 screws. There are additional 2 screws on this side, and then I think we can take out this unit in this direction. I will flip around the receiver by 90 degrees to prevent the unit falling down and bending the contacts of the plugs. The plugs are rather sensitive. They have small pins to prevent the damage when this unit falls down. Okay, it can't fall down. Here's the processor unit, but I will flip it around by 90 degrees and then try to lift it up. We open these 2 screws. Then it should be possible, or not. Ah, it is a switch. Yes. Yes, hooray, hooray, it is out. Now we are at the end of part 1 of the video about the R&S EK070. There is still some work to be done in the power supply. Stay healthy, stay tuned, see you on this channel.